Hello, I welcome you all. The problem reads the double link grip is used to lift the beam in the to lift the beam. If the beam weighs 4 newtons, determine the horizontal and vertical components of the force acting on the pin at A and the horizontal and the vertical components of the force that the flange of the beam exerts on the jaw at B. Right, this problem is coming from the engineering mechanics statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to find the vertical and horizontal component at A as well as at F, which will be similar to the values at B. And when you look at B, okay, ideally you just expect a vertical component, but we are also being asked to determine the horizontal component. So this horizontal component maybe is coming from the friction force between the flange, okay, and the base of this gripping mechanism. Okay, we haven't been told in the problem, but we've been asked to find the vertical and horizontal. So I'm saying the horizontal maybe is coming from the friction. All right, so we are going to indicate both the vertical. The vertical, we already know it because when you look at this problem is symmetrical about this line. Okay, we've seen this line I'm drawing, symmetrical. Okay, so it means the results on the left, you expect them to be the same as the results on the right. Of course, at the pin A, you expect the results to have opposite signs, but they will have equal magnitudes or equal values. While on the F and B, you also expect results to be the vertical will be equal in direction, the same in direction as well as magnitude, while the horizontal we expect it to be equal in magnitude but opposite in direction, right? Okay, so what we are going to do to start with is we are going to use the joint method at joint D so that we find the force in the link our two force member DC and DE. And when you look at these members again, the angles in between are the same, is symmetrical, so expect the force in DE to be equal to DC. Right. So let's jump into the problem. So let's go to joint D, like so. So we have joint D like this. We have a force on top. This force is equal to the weight of the flange, and this is 4 kilonewtons. And then we have these links. These links, this is link DE. These are two force members, and we have another link there, DC. The angle in between these is the same. Okay, like I said, this is symmetrical. All right. So let me call them. Let me say DE. Let DE be equal to DC be equal to T. Okay. So with this information, I can apply the equations of equilibrium in the vertical direction, which is summation of forces in the y equal to 0, like so. And then I'll say 4 minus, since there are the two of them, I'll just call them T. So I'll say minus 2T cos 45 degrees equal to 0. And therefore T, which is equal to DE, which is equal to DC, is equal to what is it? It's 4 divided by 2 cos 45. Okay, let me just call it 2 cos 45 to avoid decimal places. All right, so this is our result here. So what I'm going to do is now I'm going to draw the free body diagram for the remaining members. This member here in red I'm showing, and the other one in green. You've seen the other one I'm just tracing in green. All right, so we need to draw them. I'll need to draw the free body diagram. So let me start with the one in red. So the one in red, it is going to be something like this. Okay, something like this. Let me say something like this. So since this is symmetrical, the weight of this flange will be shared by B and F in the vertical direction. So here I expect a force half of 4 kilonewton. We'll be doing this flange weighs 4 kilonewtons. So this will carry 2 kilonewtons. Okay. I guess you know where that is coming from. This point here is A. And then we have another point there. At A, we expect a force, let's say AY and AX. And then at D, we expect a force in this direction, right? Remember, we calculated this already. We calculated that. So this one we called it T, or is this point here is E, right? It's E. Yes. So this we calculated this as our DE, right? Remember, this was our DE, and we said DE is equal to 2 divided by cos 45. And then we are going to have two components here. We'll have one component in this direction and another component in that direction, like so. And this angle here, okay, this angle is 45, all right? So DE cos 45, this gives us just a 2 kilonewtons here, right? And the other one also, DE sine 45 gives us a 2 kilonewtons, okay? Right. And then we give it dimensions. Dimensions from E, in fact from A to B, this point is B. From A to B, from there to there, it looks small. Okay, let me get black. From there to there, this dimension here is 280, okay, millimeters. And then from E to B, this one is a little bit, from E to B, so we have two dimensions. We have 160 plus 280, right? Okay, plus 280. So this is a 440. So this one is a 440, right? Is that fine? And then we have these dimensions. These ones are just pretty straightforward. So this is 120 and this is 280. All right. There we go. Just draw another one. Can I just wrap this solution here? Okay, I'll draw another one somewhere there like this. Okay, something like this. Okay, it bends a little bit. All right, something like this. This point is C. This point is C, and we expect a reaction, in this direction that we already calculated. And this one was DC, and we found DC to be equal to 2 over cos 45. We are going to have two components also, one component in that direction and another component in that direction. So this DC maybe is not well written. All right, let's write it somewhere. So we have DC, and DC is equal to 2 divided by cos 45. Okay. DC is equal to 2 divided by cos 45. All right. So we said we are going to have two components with this angle 45. So both sides, cos and sine, if you are to take components of this on either side, you find that you have a 2 this side, like in the other case, and a 2 that side. And then we have this point here, which is A. So it will be just opposite signs. This is AX, and then this other one will be coming down like this, which is AY. And then here you expect also a 2 kilonewtons. This point here is F. Right. So the dimensions will not also be different. We have this one here. This one is 280 millimeters. And then we have this one to the point where we have C, like so. This one is 440. All right. And then the heights are the same. These ones, they are the same, like in the other case also. Everything, in fact, is the same. Like we said, this is what? This is symmetrical. So with this information, we are good to go. With this information, we are good to go. Let's now apply the equations of equilibrium for each one of so we are going to take moments about F and B, and then we are going to have two unknown equations for AX and AY, and then we can solve them simultaneously. All right, so let me start with summation of taking moments about F. So the summation of moments about point F equal to 0, anti-clockwise being my reference. So what do I have? I have minus AY. AY is the negative moment, is clockwise by 0.44. I'm converting them to meters. By 0.28. Right. 28. And then we have plus AX by 0.28, and then we have plus 2 kilonewtons by 120 plus 280, that's 400, right? 2 by 0.4 and plus 2 by 0.44 equal to 0. So if we are to write this equation, we have 2 by 0.4 plus 2 by 0.44. We have a minus minus 0.28 AY plus 0.28 AX plus 0.28 AX, and then plus 1.68 is equal to 0. So this is one equation. Let's work on the other one. summation of moments about point B equal to 0, anti-clockwise being our reference. So what do we have? We have the replica, but it's only that the directions changes. Okay, so we have minus ay by 0.28 minus ax by 0.28, and then we have minus 2 times 0.4, and then we have minus 2 by 0.44 is equal to 0. And therefore the equation that we have there is minus 0.28 ay minus 0.28 ax minus 1.68 equal to 0. So we have these two equations that we can solve simultaneously. So let's do so. Let me collect this equation. I collect this one. I bring it over here so that we solve this equation simultaneously. Alright. Something like this. So we can solve this using substitution. Let's do the summation. If we did the summation, this becomes minus 0.56, right? Ay. This one becomes 0 plus 0 equals 0. Therefore, ay is equal to 0 kilonewtons. And if ay is equal to 0 kilonewtons, we can find what ax is. Ax, therefore, if you replace 0 in either this equation or this equation, it doesn't matter which one you pick. So maybe let's pick this one. Let's pick anyway, it doesn't matter which one we pick. So let's put 0. So if we did so, ax gives us we pick this one. If we did so, ax gives us 1.68 divided by 0.28. So this is going to be equal to negative 6 kilonewtons. The negative here just indicates that the sign has to change. It has to be the other way around. Okay. So with this information, so we are saying ay is equal to 0, while ax is equal to minus 6 kilonewton. Alright, so I'll need to wrap this because we want to find, I forgot this component, sorry. They told us to say we also have a vertical force, a horizontal force here. Sorry, on the free body diagram I should have indicated that. We have also this component here that we don't know. Alright, okay, I'll just assume them to be in the same direction. So these ones are what I'll call this fx, then I'll call this bx. Okay, sorry, I'd forgotten to indicate that. We have this, like I was saying initially when we just started the problem, to say maybe these are coming from the friction or I don't know. But we've been told there is a horizontal component also here. Okay. Alright, so we found what ax is and ay. So I'll need to get rid of this so that I have some space. Alright. So now I'm going to use just this free body diagram, just this one, okay, to sum up the forces in the x direction so that I find, because we found everything right now, ay here we've been told is equal to 0, then ax, this ax here we've been told is equal to, let me write it somewhere here so that there's some space. This ax we've been told is equal to minus 6. Alright, so now I want to use this equation to sum up the equations, summation of forces in the x direction. So summation of forces in the x direction is equal to 0. So what do we have? We have minus 2, and then we have minus ax, okay, and then we have plus fx is equal to 0. Therefore, our minus 2 ax we've already calculated is a minus here. All right, I'm just in the I've not changed the sign, okay, because I've taken the way we had assumed, right? Okay, if I change the sign I could have given it a positive value. So here it becomes minus 6. I hope you are following, right? Yes, I know you are following. Plus fx is equal to 0. And therefore our fx is going to be equal to, our fx here is going to be equal to minus 2 plus 6. This becomes plus 4, therefore this is going to be equal to minus 4. Is that 4? Minus 4. So it means this is supposed to also be in the opposite direction. Okay, so this is minus 4. Okay, so if this is supposed to be minus 4, then of course the other one will just be in the opposite, in the other direction, right? Okay, so there we go. I think we are done. So now I'll just need to change the directions. So let's change the directions. So the actual directions for this, we are supposed to have ax in that direction like that, and the other one like so. All right, so let me rub this. I rub this. We give it the right directions. We rub this. So that is how ax is going to appear, and this ax we've been told is equal to 6. And then this other one here, the direction also changes. This one, okay, this one, the direction is going to be like this, and so is the other one, this one. Okay, oh no, this one is fine, this one is fine, this one is fine. Okay, so these ones, this fx is equal to 4, and then this bx is also equal to 4. Right, so let's have the final summary of the solutions. So we have at A, we have ax is equal to 6 kilonewtons, and then we have ay is equal to 0 kilonewtons, and then we have fx is equal to 4 kilonewtons, and then we have fy is equal to 2 kilonewtons. All right, fy which is equal to, sorry, here I need to say fy which is equal to fy is equal to fy which is equal to by is equal to 2 kilonewtons, and then here fx which is equal to bx is equal to 4 kilonewtons. All right, I think this is about it. And I hope the video was helpful. If it was, give me a thumbs up, like my video, share my video, and continue subscribing. Bye bye, and see you in my next screencast.